From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 317, recorded live Thursday, April 26, 2012. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at GesturePak.com. In this episode, Scott talks with former Space Shuttle Flight Controller and current International Space Station engineer, Holly Griffith.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and we've got on the phone Holly Griffith, who is a flight controller. She works at the Johnson Space Center, and she's done some work in space on the Space Shuttle. Thank you, Holly, for being on the call.
Thank you for having me.
So I hope you forgive me. I'm looking at your LinkedIn, and I'm looking at every other word is a word I don't understand. And I thought I was pretty technical, and I thought I was pretty smart, but it reads like a periodic table of elements.
I hope it's not that bad.
No, I just think it was interesting because I thought I was technical and I thought I was an engineer, and I'm really it's interesting when I look at other people's industries to kind of juxtapose the different kinds of engineering. I mean, you're a mechanical engineer, is that correct?
That's right.
And that's your training. And you, what kind of work have you done in mechanical engineering as it relates directly to things like space and aerospace?
So you're right. My degree is mechanical engineering. When I first got out of college, I worked for about 9 months at a small aeronautical company where we would do some design work for airplanes and things and repairs. But my goal had always been to be at NASA, so I kept putting in my resume, and I finally got called here. When I got hired on here, I was actually hired into the electrical power system department for the Space Shuttle. So I spent about 7 years doing more electrical engineering than mechanical. And then just recently, this past August, after the shuttle was retired, I got hired into the mechanical and maintenance group for the International Space Station. So now I'm back to doing more mechanical engineering.
Wow! And you were the lead power systems officer for 5 shuttle missions, and you've supported up to 19 different shuttle missions. Is that correct?
Yes, I think that's right. Let's see. Actually, like 21. 19, 20, 21, around there.
Wow. Okay. When you're a mechanical engineer by training, by educational training, and then you said that you kind of you went from maintenance, you moved into electrical power, and you're moving around like this, are they ever saying, oh, well, you're going to need to go get another degree? I mean, how are they confident that you would be a good lead electrical power systems officer?
Well, when I was interviewing, they did say, typically we like to have an electrical person, a degreed electrical engineer in this position. But really what it is it's the engineering background that you know how to think. You can think outside the box. You're a good problem solver. Because if you have that background, they can teach you what you need to know in terms, of that specific system. So, a lot of times they prefer to have the degree, what your degree is in, then you go into that system. But that's not always the case. So we'll have, when I was in the electrical systems group, we had other mechanical engineers, we had aerospace engineers, and we had electrical engineers.
And can you tell them apart? I mean, do they, in the sense of, do they use different terminology, or do you ever talk to someone and you say, wait a second, I don't think this guy knows the difference between ohms and amps, and what are we going to do about that? I mean, what if someone has a major gap in their knowledge?
Oh, well, then that's a different problem. That's a different problem. Because, in engineering, you have, even though I was a mechanical engineer, I had a few circuits classes, so I had to take electrical engineering classes. And the same thing with the, electrical engineers. They have to take thermodynamics. So you should have that background. And if you don't, if your knowledge, if you don't have that basic knowledge, then that's another problem. You probably don't need to be working on the space shuttle.
Yeah. But you can't know everything, though. How do you keep track of what you're supposed to know and what you're not supposed to know? Because you're working on such a large system that I assume arguably is a system that no one person can hold in their brain something as complicated.
Right. You're right. And that's why we train for so long. To get up into the front room, to get fully certified, take about 5 years of just, training. But yeah, whenever we first get hired on, they literally put this stack of books on our desk, these like workbooks. And it's for the first few months, you're just reading. And so you kind of get a grasp of the system. And then what they did was they sent us to this thing called Training Academy. And that was a couple months. And you'd go every day and they would teach these classes. And it was over all the systems of the shuttle and the station. But it was still kind of basic. But it gave you a big overview of how all the systems work together. Then, after Training Academy, you come back and we would have these things called FCTs, which is flight controller trainers, and you would have an instructor and you would be in front of a computer and you would see, simulated data that you would see on console, and they would just put failures in. And so, you were still learning about your system, but as you learned, the failure modes that could happen, you were also learning your system then as well and how to handle common failures or more basic failures. And then after you had done that for a while, you would actually start simming on console, where you have the whole flight control team, the flight director, and the crew is up in the simulator, and we have a whole training team, and they just throw failures at the team. And that's when you start really working with, the other people who are on console, and you see how the groups interact and how a failure in their system would impact your system and vice versa. And so it's just, these flight controller trainers, you would have 2 or 3 a week. Sims, you would do 2 or 3 a week. And so you're literally, for a while, just in this constant training environment. And so doing that, but you still can never know everything about your system. We still have failures on console where people are like, what is this? I've never seen it before. And so that's when it's not just you and the other person you're working with. It's, if you have time, that problem is solved by, the next team comes in and they look at it, and the next team comes in. And then during flights, when we were on console, we would have the MIR, which is the Mission Evaluation Room, and they would be engineers in that system who, they weren't on console, but they helped design the system or they would work on it in other ways. And so we would have that whole engineering support team behind us too. So it wasn't just up to you to know everything all at once.
It sounds so much, forgive me for I've only made it 7 minutes into the show before the Star Trek reference, but this is some kind of a Kobayashi Maru kind of simulation thing where it's like, they're going to give him failures and he's going to refuse to allow the failure of the simulation to affect his outcome. I kept hearing in what you were talking about, failure. You're trying to make as many things go wrong before the actual thing happens so that nothing goes wrong.
Right. Or if it does go wrong, you've seen it before. So the Kobayashi Maru, those did happen. We did have sims where that would happen. Not very often. If that happened, it was not on purpose, because the point of, the training team was they didn't want to put us in that situation where, no matter what we do, something really bad happens. They wanted us to be able to work through the failures. And so if a Kobayashi Maru situation happened, it was done on accident where, we just didn't realize, there's so many failures deep at that point that we didn't realize by doing this, it would affect this in a certain way. And so we would have a debrief after every sim with the crew and with the training team, and that's something that we would talk about. But, the point of the sims was not only to help you learn your system, it was also to help you, especially the really high stress sims, was to be in that environment as close as you can mimic it, so that if you got into that situation on console, you didn't just freak out and run away or something. You were used to having that stress. And so you were used to being able to sit down and say, okay, what do I need to do? This happened. And almost you go into kind of a robot mode, and that's what they wanted.
See, that's interesting too, because that makes me think about training. And by training, I don't mean basic training like this, training of going to college, but training like Navy SEAL training. When someone's like, yes, and then my training kicked in and my hands were moving and my training had kicked in.
Exactly. You see this failure. Well, you have to go to this procedure and this step in this procedure. And a lot of times you would have the page numbers or the steps memorized because you had done it so often in Sims.
that makes me feel comforted, but it also makes me feel a little sad for my own industry, because I'm trying to imagine software engineers that come into their job and are handed a big giant pile of paper and said, you're going to read for the next 3 months to know our systems inside and out, which doesn't usually happen. And then we're going to simulate failures and make sure that you know the system inside and out. And we have a tendency to assume everything's going to work okay until it goes horribly bad. If you found this to be like a very intensely professional group of people, I'm kind of juxtaposing that our groups are not all that professional.
We are. Especially at work, we're very professional. Most people who are here have always wanted to be here, so there's a true passion about what we do. So it's not only about being professional, it's because you want things to succeed, you want things to go well. So that does play into it too. But a lot of times you have this image of a rocket scientist and they're in a lab blowing stuff up with the lab coat and whatever. And I was actually kind of surprised when I got here, because everyone is just, they're normal people. We go out after work, we have happy hours, we, celebrate birthdays on the weekends. And so they're a pretty normal group of people. But when we're at work, yeah, it is, you do your job and you get it done and you do well. And you kind of flip a switch where you know when you need to be professional and when you need to buckle down and say, okay, this is bad, or, I really need to focus on this, because if I don't do a good job, then people die.
Right. Yeah. And that is something that is different. When we're stressed out in software and we're taking a shopping cart and someone's buying a book, we're not saving babies. We're not in surgery right now. And we're certainly not flying the space shuttle. So,
but we do have software engineers, that had to write the software for the computers online and for the simulators. And so it's, we do have those people that they need to do their jobs correctly too. Mm. So, maybe your particular software engineering job isn't like that, but we do have plenty of programmers and software engineers at NASA.
Uh-huh. Yeah, and I assume that are they someone that you interact with, or are they a group that is nameless and faceless? No, they're not nameless and faceless.
Flight controllers do interact with them. My particular group didn't so much. But we have the data processing system, the DPS group. They interface with them more. And then also the training team, since they were working, they would do the simulators. They would work with them, to make sure the code was correct whenever we put in a failure for a sim, that failure would go in correctly and, would affect the other systems correctly. And so they interface with them more. But no, I wouldn't say they're nameless and faceless. They're definitely an active part of, helping us out in the missions.
That's very cool. Now, the space shuttle and some of the technology behind it isn't like super cutting edge. Can you help me understand what is cutting edge and what isn't? Because when I see some of your videos, I see some older looking technologies and older looking offices, and it makes me wonder, are you working on these things that were built in the 80s or?
Yeah, the shuttle was actually built in the 70s. The station started to be designed in the 80s and some in the 90s. And then, when the actual modules started to go up in the 90s. It's hard to explain because here at JSC, I'm in operations. So you kind of don't have a choice because these vehicles, they take a long time to design. They take a long time to build. And then they take a long time to get ready to fly because you have to make sure the training team's ready. You have to make sure the flight control team's ready. So it's not a process where, you can say, oh, this is the latest cutting edge technology. Well, it might be today, but in 10 years, it's not. So with the manned spaceflight program, I would say it's not so much super cutting edge. But with other areas, of research and things that some of it's done here at JSC, a lot of it's done out in California, they're working on more cutting edge technologies.
And I don't mean to disparage by saying, cutting edge or not, but I mean, reliability presumably is more important than shine and sparkliness. But
absolutely.
But the speed at which things have developed and the improvements in processing power, I mean, I assume that my iPhone has more power than the original Apollo missions as far as like raw MIPS. Mm-hmm. But
yeah.
When can you take advantage of that? And I assume you're using the latest software and the latest systems as appropriate. I guess there's a balance between picking new technology and picking the safest, most reliable technology, because you can't have a Windows machine crash in the middle of a space shuttle flight.
Exactly. And so, yeah, that's true. I mean, for the shuttle, we had certain software. For the station, we use certain software. The next vehicle that's being designed, I think they are trying to do more, maybe touch screen or, more advanced technologies, but they're still designing it. So that's what's out there now. So that's what they want to try to use. But, whenever it actually flies, will there be something different? I don't know.
Mm-hmm. And you managed the electrical power systems for the space shuttle. So you're dealing with 30, 40-year-old electrical systems, but also I assume that some of those pieces have been replaced because you've got older wiring maybe, but then you've got new lithium-ion battery technology all in the same machine, right?
Right. Well, so the shuttle used fuel cells. And yeah, the fuel cell technology has been around for a long time. But between flights, that's what was good about shuttle, is shuttle would come home. The orbiter would return to Kennedy Space Center, and you could, bring it somewhere, and the techs would look at it. And so, yeah, if we discovered a problem with the wiring, then we would replace the wiring. The fuel cells, they had a lifetime on them, so a certain amount of hours. And then once they had flown that certain amount of hours, then you replace the fuel cell. And then obviously, if the fuel cell had a failure in flight, you would replace that fuel cell. So, and that was, that was true of every system. I mean, any time something would go wrong, whether it be the environmental system or the communication system, they would definitely go and look at what the problem was and then fix it with new components, or replace whatever needed to be replaced.
Are you involved in those kind of decisions? I mean, as a power systems person, do you make suggestions, or is there someone else who is deciding what new parts are going to be introduced into a complicated system like this?
You could make a suggestion, but really that decision was made at people at a higher pay grade than ours. Because it's not just up to us. You have the vendors, you have the people who make the fuel cells. That's another contractor. That's not NASA. So they're the experts on the fuel cell itself. We operate it, but they design and build it. So whenever there's a problem, we generally defer to them, like, okay, well, what do you think? And then they make a suggestion, and we look at it from an operations point of view. So it kind of goes back and forth, but for the most part, it's their decision.
I noticed that you did some work on a fuel cell cooling problem that you mentioned in your LinkedIn here, where you got a performance award. What was the problem with the fuel cell during STS-127?
So we, trying to explain it the best way here.
Don't dumb it down too much. I'll do my best.
So the fuel cell has to stay within a thermal limit, right? It can't get too hot and it can't get too cold. Mm-hmm. And so if it does, then you have a problem. You could flood the fuel cell, or the fuel cell could dry out, and that's not good. So we had gotten into a situation where a component wasn't functioning exactly as we expected it to, and the fuel cell was running hotter than normal. And so we, this was pre-launch. And so that's a big part of what we do. You have this problem. We're on the ground. We want to launch. There is pressure to launch. If there's something wrong, we won't do it. So, I don't want you to think it's back like Challenger. No, we just have to go. We have to go. No, the culture has changed so much since then. But there is still some pressure. You've invested a lot of time and money, and you want, there's other people depending on you, and so you want to try to go up. So we're looking at this problem pre-launch, and we had, we called in our engineering people. We had meetings galore for days and days and days. And finally, we decided, okay, we have 3 fuel cells. This problem, looking at it, we have some data on it. We don't think it'll get worse. If it does, it's not, and the crew's not in danger because we have 2 other fuel cells, and so we can rely on them. So at the end of the day, we looked at the data, and we looked at the history of the fuel cell and what we thought could happen, and we mapped out every failure scenario that we could think of. If this, then this. If this, then this. And we, changed some things, looked at procedures, see if those needed to be changed at all. And then at the end of the day, we were like, we think we're okay to go. And so we ended up launching.
Wow. It sounds like chess.
Yeah, it kind of is in a way on some things. That when I was talking about the sims, that's kind of what the sim team tries to do too. Is not necessarily the Kobayashi Maru scenario, but not every failure you have is like, oh, well, this failed, we do this, we work this step and this procedure, and that's it. It's a lot of times they want to test your gray area. Well, I don't know, it could be this, it could be that, and then if I do X, then Y happens, and if I do Y, then Z happens. So what is the lesser of two evils? And we have flight rules that help guide us, that tell us how to operate things in flight. They definitely don't cover every scenario because there's no way you can think of everything. But once you get into one of those gray area cases, then that's where you're like, okay, I recommend we do this. Here's my rationale. You pull out a flight rule, you pull out past flight data, you pull out your engineering experience, and that's the point of the Sims, is to get in those scenarios and think about what you're going to do. And so that, that type of thinking, which we had done that in Sims, not for this particular case, but in other cases, it helps that thinking process of, like I said, you go into that mode of, well, I need to do this and this and this and look at this data and look at that data, and okay, here's what I think.
What did they end up doing with that cell? When they come back, they replace it, or they just keep it in that state? At some point, something needs to...
I think they replaced that one. I think they do. I'm trying to think back. That was a few years ago. But once, we got on orbit and it was okay. But when it came back down, I do think that they replaced it. But I would need to go check on that to be sure.
What kind of fuel cells are they? Like, what is the electrolyte substance for the fuel cell?
It's potassium hydroxide, KOH.
And is that something that is at a high temperature? Is it a high temperature fuel cell, or is that a...
Well, I mean, that's just the electrolyte. Are you talking about the actual cryogenics?
Yes.
The hydrogen and oxygen. So that's the fuel for the fuel cell. So we have hydrogen, and they're cryogenic hydrogen and cryogenic oxygen. So they're kept very cold, but at higher pressures. They go into the fuel cell. Whenever they combine, you have the reaction with the electrolyte, and that produces the power, and then it also produces water. So the crew would drink the fuel cell water, and they had pure, not contaminated, completely pure water to drink. And then it would also produce heat. And so that heat would go into the cooling loops, and the cooling loops would, take the heat away. And then we had the radiators, and it would go out into space.
Rather than using the heat to, I guess, heat their living quarters. I presume it creates far too much heat for that purpose. That was the electronics in there produced a lot of heat also. And so we had a water loop, and we had freon loops, and they would take that away and also vent it, or I shouldn't say vent, but radiate it out into space. And do you think, having worked so much on fuel cells and seen what they can do, and the idea that someone can actually drink the exhaust, that's the way things are going, and we should be using those and not running around in Priuses and hybrid cars?
I mean, I don't feel like I'm qualified enough to answer that, because I say that, yes, I do think fuel cells are a good way to go, but I don't feel like I know enough about the other methods that are out there to make that decision. So,
that's a very scientist answer,
batteries well, I just feel like I'm not,
I was more curious about your personal opinion. I didn't mean to.
I think fuel cells would be a great way to go, but maybe I'm a little biased.
Well, I'm sure you are biased, because they've worked very well for what you've accomplished.
Yeah, they worked great. The fuel cells we used, we didn't have many failures. They worked really good, and the failures that we did have were generally small, like a flow meter, something that would measure the flow rate of something. Really just a transducer. It would go out, or so it wasn't a problem with the fuel cell itself per se, but just something that gave you more instrumentation.
Changing direction a little bit, is this a 40-hour-a-week job? Is this a 9 to 5, or is this something that just you're always going 100 hours a week?
When we're no, and that's actually that's a good question, because that's one of the aspects of the job that I really like. I feel like if it was just a 9 to 5 job every day, I would get bored. But so Sims, sometimes you try to have 2 Sims a day when we still had shuttle. You'd have an ascent entry sim, those would be about 4 hours, and then you would have an orbit sim, which could be 7 to 8 hours. So you try to fit in 1 orbit, 1 ascent entry every day. So some sims you would be there at 7, and get out at 12 with the pre-brief and the debrief. And then
is that 7 a.m. and midnight?
What?
You said 7 to 12. Is that 7 to noon or 7 to midnight?
Oh, 7 to noon. I'm sorry, 7 to noon. So it's about 5 hours with, the 4-hour sim, and then you have a pre-brief and a debrief. And then some sims, to let the team reconfigure everything, you start at 2, you get there at about 1, and you would have the sim from 2 to 10. So you would work from 2 p.m. To 10 p.m. During flight, now we had to be there 24 hours a day. So we had 3 teams. We would work 9 hours because we had a handover before and after. So one team would be on, then the next team would come on. They would come on an hour before that shift would end to, get handed over, like, well, this is what happened, this is what we've been doing, just to kind of get caught up. And then they would work their shifts, and then the next team would come on an hour before they got off, and you would do the same thing. So you could work midnight to 8 a.m., you could work 9 to 5, or 9 to 6, you could work 6 p.m. to 3 a.m. I mean, that was all dependent on orbital mechanics, when the shuttle launched, where the station, but you had to make that decision based on the station's orbit when the shuttle would launch. And then every day that we would delay, that would get earlier by about 25 minutes or so. So you could start out with a great shift of, not having to come in until 10 o'clock in the morning. But then if you have a lot of delays, you could be coming in at 6 o'clock in the morning. So it's like, you had good hours, but now you don't.
Wow.
So, yeah, we would work during flights. We would work around the clock, 7 days a week. It didn't matter. I think I worked 2 or 3 Thanksgivings in a row for a few years. Because, you can't stop. It's like, it's Christmas, gotta come home. No, it didn't work that way. But,
wow.
It was fun.
But it balances out? I mean, you're not burning out?
Right. So then after the flight would land, it's kind of go for about 2 weeks for average flights. And then once you land, everyone kind of took some time off because you had gotten so many hours during the flight that, you had vacation time that you could kind of chill out for a few days. Things quieted down around GSC. And then you would start getting ready for the next flight, which is probably in the next few months, 3 to 6 months. And that's when you really start your simming and your training for that flight. But, those days were definitely not as hectic as whenever we were flying. And so if you're not on sim, then you're just in the office. And, unless there's a big issue going on or you have to work a big project, then that could pretty much be a 9 to 5 job.
One of the things that I wanted to ask you was that I always knew that I was kind of geeky and I was always taking things apart and putting them back together. Mm-hmm. And I don't know why disassembling the toaster and reassembling the toaster turned into a job at Microsoft. But I'm just curious, were you doing that kind of stuff? Were you taking things apart? Were you doing rockets in the backyard when you were 5?
I was not. A lot of people here were. I like the more sciencey aspect of it, and that's why I think I really like operations. I just like the operations part. It's kind of built and it's done. Now, how do I work with it? That just interests me more. That's what I gravitated to, more of the research. I did engineering because I thought, I've always wanted to work here, and that's been my dream since I was about 4 years old. So I kind of looked into, I want to work at NASA. What do I need to do to work at NASA? Oh, engineering. And so I did like my engineering classes, but I was not the person who was, taking my car apart or my toaster or whatever it may be and putting it back together.
But you said you knew this when you were 4 or 5.
Yeah, I have a picture of me that my mom found. I was actually 2 years old, and I'm standing there wearing this Johnson Space Center shirt. And so I don't know, maybe it started back then. Maybe we had just taken a trip to Johnson Space Center and got a shirt. But so I like to say, see, this is proof it started back then. But really, I did start getting interested in it when I was about 4 or 5. I was reading the books, the picture books and stuff on space, and watching shows on science fiction shows on space and things like that.
Now you're involved deeply in the process, but did you ever think about actually going up, or is there ever an opportunity for someone who works in the main room to go up as well?
We have had a couple, I think at least one person, maybe 2 flight controllers who became astronauts. That is something I always wanted to do. That was my dream. there's, I don't know if, I think they may have changed the rule now, but I had gotten LASIK eye surgery, and so that disqualified you, kind of from the get-go. But I just have a bachelor's degree in engineering, and that you get here and you look at these astronaut bios and you're like, oh my God. Yeah, I'd have to go back to school for a really long time and, either get a PhD or go into the, Air Force and be a test pilot. So, it is something I would like to do. I don't know if I'll get to do it. Maybe now with other, commercial companies and space tourism and things, maybe I'll get to do it one day, but not in the near future.
I was trying to figure out what the right amount of money it would be. Like, I think famous people are spending millions. Would I spend 50 grand to go to space?
50 grand?
If I had 50 grand. I'm thinking about, like, what's the price point for me going to space? What's the amount of money where you're like, all right, I'll defer my retirement. I'll pull that money out of my 401k and go to space. I can do that.
I don't know. I know Russian was taking space tourists up to ISS for a week, and that was 20 million. I think Virgin Galactic had said that they could do it for 200,000, but that's just, you kind of go up in your wait list for a few minutes and then come back down. So whenever other companies actually if they start doing the space tourism, I'm not sure what the price tag would be on that. If there's a lot of demand, maybe it would go down eventually, but I don't think that's been set yet.
Yeah, I've seen people I've seen a couple of VCs and rich people on Twitter that I know change their Twitter bios to include Virgin Galactic astronaut number 600 and whatever. And I'm like, well, you're going to space. You're kind of just going up really high.
Yeah. Yeah. But, I guess it's better than nothing if it's kind of the only show in town right now. But hopefully, the other companies really start coming up to speed and it becomes more normal and more of an option, and it doesn't take your life savings to do it.
Yeah, exactly. I don't know if I need to have another mortgage.
Right.
In conclusion, I just wanted to also point people to the Space Tweep Society. Can you say something about what the Space Tweeps are?
Space Tweep Society. So SpaceTweepSociety.org is it's an organization for people on Twitter, and you don't have to be active on Twitter. You just need a Twitter. You need to have a Twitter ID and logged into Twitter, because that's how the account works through the website. But so a few years ago, when Twitter was somewhat new, myself and some other people noticed that there was a big space community on Twitter, and we're like, wow, we all kind of follow each other, but maybe this person would follow another person, and you wouldn't know, you wouldn't really know who to follow. This was before Twitter was doing a lot of the recommendations and things. And so we started the Space Tweep Society, and it's kind of a place to go where if you're on Twitter and you're interested in space, you can sign up and you can meet new people and, follow people who you wouldn't have otherwise followed because you didn't know about them. And when NASA started doing their tweet ups, we would actually have our own Space Tweep Society tweet ups as well. We did a few of those. I never got to attend because I was always working accent over here, so I couldn't go. But it's just really a place for people to go who are interested in space and who are on Twitter and just, like to talk about space and like to, that's their passion, and it's a way to share it with people.
That's great. And you're a founding member?
I am. I'm one of the founding members. Yes, me and actually at Flying Jenny on Twitter. She's really the brains and the workhorse behind the operation. She did a lot of stuff, and it was really her brainchild. So I helped out where I could, but she's very talented in everything when it comes to art, science, whatever. So she actually designed our little mascot, who's a little Twitter bird, but with a spacesuit on. And so we had a contest to name him, and we named him Miko, which is when you get up in space and you're finished, then the main engine's cut off, and so we call it Miko, main engine cut off. And it's a popular call sign whenever we get to that point in orbit. It's like you hit Miko, and it's, oh, okay, we made it, we're done, we're safe. For now, we made it from the ascent portion of things. So anyway, I'm getting off track, but that's Miko. That's the little mascot. And I think it's been a very positive experience for a lot of people.
It's fantastic. I will add links to the Space Tube Society and your
Excellent.
Twitter and her Twitter, and we've mentioned as well as information about some of the things that you've worked on. Thanks so much for taking the time to chat with me today.
Thank you for having me. It's been great.
This has been another episode of Hansel Minutes. I'll see you again next week.